Number 12 says, calculate the resistance of the 40-watt lamp. Show all work, including the equation and substitution with units. Okay, so we have this diagram here. It says that there are 3 lamps connected in parallel to a 120 volt source of potential difference. Again, potential difference is a fancy word for voltage. It's like a battery is the potential difference. Okay, so this one is asking specifically for resistance, and it wants the 40-watt lamp. So we have to know what watt means. So when it says 40 watt, what is it talking about? Well, in this case, watt is the unit for power. So that means that the power of that lamp is 40 watts, and we want the resistance. Okay, so we're going to need to use something that relates power and resistance. So if I look in the reference table at the power equations, P equals I times V, which is the same thing as I squared times R, which is the same thing as V squared over R. Okay, so we want something that has R in it, so we can eliminate that choice. So we could use maybe this one or maybe this one. So which one's going to be easier for us to use? Well, in a parallel circuit, we know that the I's are going to add, the currents are going to add, and the voltages are going to stay the same. So if I know one voltage, I know all the voltages. And in this case, it's 120 volts here, so that means every single one has 120 volts. So it's probably going to be easier for us to use this equation than this one, because we'd have to solve for I and go through that whole process. So we're not going to do that. We're going to be smart with what we pick, and so we're going to pick the P equals V squared over R. So in this case, 40 watts equals 120 volts squared over R. I'm going to multiply by R on both sides and then divide by the 40, so it's going to be 120 volts squared divided by 40 watts, and when we put that into our calculator, we get 360 ohms. And that is the resistance of the 40-watt lamp. Okay, number 13 says, describe what change, if any, occur in the power dissipated by the 100-watt lamp if the 60-watt lamp were to burn out. Well, if the 60-watt lamp were to just burn out, go away, well, the resistance stays the same of this one, the voltage stays the same, and the current actually is also going to stay the same because it's going to get redistributed through these paths, and really where the current will change is here. So everything stays the same. So what would happen? It stays the same. It's still going to only draw 100 watts of power. Okay, describe what change, if any, would occur in the equivalent resistance of the circuit if the 60-watt lamp were to burn out. Well, if the 60-watt lamp were to burn out, this whole equation, 1 over R1 plus 1 over R2 plus 1 over R3, so what would happen is that's going to change the whole system here. So with the parallel circuits, it gets smaller. As you add more resistors in parallel, the total REQ gets smaller. But if you were to take one away, it is going to increase. So the answer for this one is increase. And we can prove that mathematically. We would have to, I don't want to solve for all the resistance for all of them and do it mathematically. But if you think about it, like if this one goes away, what's going to happen to this, right? That's the way you want to think about it when you're thinking of how to solve this. All right, and then number 15, the circuit is disassembled. The same 3 lamps are then connected in series with each other and the source. Compare the equivalent resistance of the series circuit to the equivalent resistance of a parallel circuit. Well, we know for a series circuit, REQ is R1 plus R2 plus R3. So if we were to draw these in a series circuit, it would look something like this, and they would all just add. And a parallel is going to be like what it has up at the top. And that's 1 over REQ equals 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so comparing them, we would see that REQ is obviously going to increase because these are just being added together without any reciprocals or anything. So this is going to increase. Okay, and that is it for the review packet. The Unit 5 test looks very similar to this. Same idea as solving circuits, knowing those equations. In terms of the COVID-19 situation, I'm not sure what our unit test is going to look like for this. I'm going to have to think about that. But at the very least, you've done the review now, and that's good. All right, that's it.